So we often hear that because a tape attaches to the skin that it can't possibly affect mechanics. And really what we're talking about here is kinetics quite often. So can we introduce a force that crosses the joint, that changes the joint moment there, and in doing so reduce the required workload of the structures that would normally create that force? Or maybe by introducing a force we can actually change things like position, so change our kinematics, our movement, our position, and in doing so, once again, that can also have an effect on our kinetics by changing lever arms, either of things like the ground reaction force or of the muscles that are acting upon that joint. It can change things like the axis of motion, for example, your subtalar joint axis and so on. So this is just a quick demonstration. We're looking at the Achilles tendon or a calf type application here. And I just wanted to pay attention to a couple of things. First, have a look at the resting angle here when there's no tape in place. Also have a look at the way the foot springs back, and then the force that's required to take this through full dorsiflexion. So you'll see here as we go down, that takes about 3.2 kilograms, 32 newtons of force, and we see it spring back there. If we go a little faster, we just reproduce that here, it's about 3 kilograms again. A little faster, we're only getting about 1.8 kilograms or 18 newtons of force if we move at speed in that outer range. Again, there's 2.3. Now with the tape on, let's have a look at our angle once again. And we're now actually resting in full plantar flexion. Again, watch what happens now as we come down. We actually already hit 3 kilograms, we're not even at plantar grade. If we keep going to end of range, then it's well up over 8, almost 9 kilograms, and you can see it spring straight back, and it springs back into that same resting position, full plantar flexion. Now if we go with a little speed, we can see that's out 13.5 kilograms, and if we just do it in outer range with speed, we're still 7 kilograms, 7.5 kilograms of resistance, and we're not even reaching plantar grade, so that's just in that outer range of motion. So we'll often use this technique for calf tears, for our Achilles tendinopathies, particularly those reactive ones where we're trying to get an initial reduction in load to allow them to settle down a little bit as we reintroduce the load in a way that they can handle it. It may be in transitions where we're increasing the amount of activity and there's potential for them to relapse a little bit, or it may be in those late stage sort of degenerative tendinopathies where they've lost their own intrinsic energy storage and release capacity within the tendon, and we can tape them to give that to them sort of externally, and they will say they feel like they have a bit of a spring back in their step once again. So we may be able to maintain function even though we're not directly going to reverse some of those more permanent changes in the tendon itself. But as you can see there, you know, we're getting 5 up to 10 kilograms additional resistance to dorsiflexion. So every time that foot lands on the ground, the tape is absorbing or taking some of that load off the structures that would normally have to control that. And if you're a marathon runner or you're a jumper, a volleyballer, then that can add up to a very significant amount of force throughout an event or throughout a training session or throughout a season.